Welcome to my channel AI is Fun. So today we will start with RAG and I will explain you what is RAG and how we can create an architecture of RAG and what are some advanced technique in which we can achieve a better result by using any LLM in RAG. Okay, so let's understand RAG first and then we can move forward with that. So RAG is retrieval augmented generation, and it is the process of optimizing the output of a large language model. So it reference an authoritative knowledge based outside of its training data source before generating a response. It basically means large language models are trained on a vast volume of data and use billions of parameters to generate original output for tasks like answering questions, translating languages, and completing sentences. But RAG extends the already powerful capability of LLMs to a specific domain or an organization internal knowledge base, all without need to retrain the model, and it is cost effective approach to improve LLM output so it remains relevant, accurate, and useful in various use cases. Let's understand why we need this kind of approach to generate the response. Okay, so let's understand first that LLM are key artificial intelligence technology powering intelligent chatbot and other NLP applications. The goal is to create bots that can answer question in various tech contexts by cross-referring authority knowledge source. But unfortunately, LLM might hallucinate. It might not have the information of your organizational knowledge base or your personal data. Okay. So in that context, it may not respond accordingly. It might hallucinate or it can give inappropriate answer based on query. For example, if you ask what is cell, in context of cell, if you are referring to biological term, you might thinking it is a small unit of our body, but it might give you a response as a cell phone or cell battery. Okay, so that things might occur, but if you give a document to refer it, then it will give you a proper response. So in that case, there is another approach which people were doing earlier when LM comes. So in that case, the people were giving some context with the query. So what was happening? There was some context length problem in which people has to pick up the specific context from their document and put it there, and that there will be a query, and then LLMs are generating the response based on both of those context and query. Okay, so now let's talk about what is the architecture of RAG so that the response is well optimized as well as it is based on your particular data. Okay, so let's go to next slide. And here you can see this is a basic structure of RAG, how RAG should be. So let's talk about first. I have a PDF file. Okay, and then this PDF file is sent to an embedding model. That embedding model will create embeddings of my PDF file, and then I'll store that embedding to vector database. That is the first step. Okay, so this looks like a really simple thing, but it is not. For example, if your PDF has 700 or 800 pages, so in that case, if we use any embedding models, most of our data will be thrown out. Okay, in that case, we don't have so much information because most of the embedding models has a size of 720, 700 or 800 vectors or 1500 vectors, that's all. But in that case it won't work. Okay, so what the approach we are doing in case of RAG, we are basically dividing our document into chunks. Okay, so suppose this is our PDF and we are dividing into smaller chunks based on our use case. So here suppose we have divided our data into multiple chunks of my PDF file. Okay, now what will happen? Each chunk will be given to embedding model, and then embeddings will created, and then we will store those embeddings to vector database. Okay, so first chunk will be created, then second and third, and so on. Okay, so that is the first step what we are doing here. And let's talk about the vector database. If I talk about vector database, in this case, what will happen? The vector stores are there. For example, there is a ChromaDB. Okay, there is a Qdrant, there is a FISS. So there are Pinecone. So there are so many vector database which is uh, used in these kind of scenarios. And here we are storing the vectors. Is nothing but the embeddings of the text. Okay, the vectors are stored in the vector database, and then we are storing with some metadata. Okay, metadata is nothing but extra information of that particular vector. In this case, we are not storing so many metadata, but we are storing the UUID, which is a unique identification of that particular chunk. Okay, now let's come back to user. I am a user and I want to ask some question regarding this PDF. Okay, so what I will do, I will write a query and ask to model. Okay, but this is the simplest thing what user will see. But what is happening in the backend? So basically, our context, like what the question I have asked, it will again given to embedding model, the same embedding model which we have used earlier, so that our vectors should be same. And then this embedding models will create embedding, and that embedding will goes to vector database. It won't store, but it will look for the similar vectors. Okay, so for example, if I ask some question, it will look for some similar vectors and pull up those chunks. If I put the similarity search value, that is k, as 5, then 5 chunks will be picked from this PDF. Okay, if I put it 10, then 10 chunks will be put as a retrieval context. Okay, then what will happen? These chunks, that is in a form of embeddings, that will converted into uh, context, which means normal human readable format, which is a PDF. So it will again convert it back to text. And then for LLM, the question will be the query which user will ask, and the context. This is the first context, this is the second context, and third context, and so on. So there might be multiple contexts, and based on the query and context, LLM will give you the response, and the response will be much more appropriate. Okay, so this is the basic idea of RAG. If you want to know more about each of these things, how we are converting into different size of chunks, and how embedding models work, what is the how we can see the embedding data, which means vectors, how we are storing into vector database, do let me know in comments, and I will definitely make a video out of it in very soon. Okay, so that's how a basic RAG structure works. But that's not all. There is so many problems with this basic RAG structure. For example, if I talk about the second one, okay, let's talk about advanced RAG, and then I will come with why we are using these advanced RAG techniques. Uh, ba- Unless we have some that basic RAG techniques. Okay, so let's talk about this first. So there are four major advanced RAG techniques, but there are so many multiple RAG techniques. For example, there is re-ranking, knowledge graph, query rewriting, self RAG, as well as there is multimodal RAG. There is so many RAGs application or techniques which can be applied. For example, there is a table RAG also there. So we have to select what is our use case and what advanced RAG mechanism will be worked for us. For example, we can even combine all of those four in a single RAG application. That also can be done. Okay. So let's talk about one by one, and yeah, we'll see how it goes. So first is re-ranking. So there are so many re-ranking models which are available on Hugging Face as well as private. Okay. For example, LLM API, for example, GPT is also using re-ranking model is there. In Cloud there is re-ranking model, and these models are also having re-ranking models. Okay, so let's talk about the first one, that is Cross Encoder. It is open source and the performance is great and the cost is medium. So here the cost directly refers to our CPU or GPU uses. Okay, it is not about the uh, amount it will take. But here the cost means how much CPU and GPU it will take. Okay, so these are examples, that is BGE, sentence, transformers, and mixed bread. We can utilize those things and use in our RAG architecture, and then response will be really nice. Okay, so let's talk about that. If you want to know more about this, do let me know. I will, share a link of these information where you can get. Okay, so this is the re-ranking RAG. Okay, here it is not only re-ranking RAG, it is also utilizing the agents for doing the same task. Okay, but if you don't want to use agents, since it is the complexity will increase, so in that case we can use the simple architecture, we can also use the re-ranking here. After we will fetch the context here, the context will be there, and then here we will use re-ranking algorithm, so that the ranking will be changed of the context, and then with the query we will pass the context. Okay, let me explain that to you in this architecture. Okay, so first, our consider we have created a chunk of PDF and stored into the database storage. Okay, so here we have stored in a database storage, but there is another thing which we are doing other than storing the vector chunks. Okay, we are also storing the summary chunks, which is nothing but our whole information of that particular PDF or particular document as a form of context. So there will be two type of context we are storing in database. First is summary of that particular document, and the other one is the chunk which I have told you earlier. Okay, so here the query is asked, then that query will be given to agents. The agent is query transformer, which we will talk about later, how query transformer works. Basically it will convert your uh, poor query to well designed query, and then query routing is also there, and that query routing will be given to vector store index, and then it will fetch the chunks of code from the database. Okay, so these are the things, and then re-ranking models will use. And consider, let me give you an example. Okay, so for example, there are 5 documents has been fetched from our database. Okay, so let's draw 5 documents, I mean 5 chunks from our document database. So consider this is first, second, third, fourth, and fifth. Okay, so there are 5 documents which we have fetched from the database, but it most likely what will happen in the previous one, the first one which is fetched from the database, it is the most match of the similarity, so it will use as a context. Okay, but in this case we are using the re-ranking post processing. So what will happen, it will again re-evaluate all of the 5 with my query, and then it will re-rank it again. For example, after doing re-ranking post processing, in this case, suppose earlier we have used cosine similarity, but here in re-ranking processing they are using so many similarities functions. In that, it found out that the fourth number should be the first one. Okay, so it might happen it thought fourth one should be the first one, fifth one should be the second one, third one would be the fifth one, and so on. So basically it might change the rank. So what will happen in the context section, it will give a response based on that fourth one, which is most connected to our query. So in that case the LLM will get the context, LLM will get the query, and then we will get the appropriate result as a response. Okay, so that's how re-ranking technology works. Now let's talk about the second one, which is knowledge graph. Okay, so in knowledge graph what happens, it basically connects the word in a graphical manner. For example, Harry Potter. I have given the example of, suppose, Harry Potter. Okay, so Harry Potter is connected to so many characters. Like it has been connected to Albus Dumbledore. Okay, it has been connected to Terence Higgs and so many persons. But if I talk about this Morgus McDouglas, whatever the name it is. So basically, it is not directly connected. Okay. So what will happen in case of knowledge graph? It will take the knowledge of that particular text. For example, if I ask about who was the father of Harry Potter, so it will check Harry Potter is connected to how many persons, and then it will check in the graph and see the text between those. If father is mentioned, then it will pick those kind of approach. Okay. So basically, these things are happening in knowledge graph. Okay. And now if I talk about how and where we will put in our architecture, so it will work as a search result. So that is smart search. Okay. So question has been asked, question is asked to smart search, then a smart search will go to the knowledge graph structure, as earlier it was doing, context from the database and retrieval, similarity search, right? So those things will happen here, and then based on similarity search, it will fetch the relevant information. Since it is a knowledge graph, so it will, if I talk about, it will fetch these information. This is Harry Potter and his father, so this is the connection. Then it will fetch both of those information and then give it back to us, and then that question will be as given to LLM as a context. Okay, so LLM has two information, relevant information as well as the context, and then based on that, it will generate the response, and response would be much nicer than the oldest approach in which we are not utilizing knowledge graph functionality. Okay, so let's that's it for knowledge graph. If I talk about query rewriting for RAG, okay, so as I have told you earlier, in this slide, yeah, in this slide, the query transformer happening with the help of agents. Okay, so in which what is happening? The query is asked, which is poorly designed since we don't ask a precise query as a user. So what will happen? It will generate the query based on our query, and that query will use to fetch the information. Okay, and then the similar approach will happen. For example, if I ask any query, it will rephrase, modify, or expand the question if necessary. Then it will route between the data stores. Okay, if I talk about, if we have a relational graph database, and if I want to fetch some information from our RDBS, okay, in that case, what will happen? It will generate the SQL query, and that SQL query will fetch the specific response, and even it will construct into the natural language, and then it will fetch information from documents as a PDF or image file, if it is hybrid or multimodal RAG approach we are utilizing. And then with the vector database and with the retrieved information from the database, it will given back to retrieval, and there is our query with LLM, and then we will get the perfect response. So basically that is another use case in which we can ask query. And the last one I talk about, which is self-RAG, and it is one of the most innovative thing which has occurred in case of RAG system. So what will happen? This is our query. Okay, let's understand with an help of example. So this is our query. How did US state gets their name? Okay, this is our query. First, what it will do, it will retrieve on demand, which is the retrieval with help of LLM. So let's LLM will give the response. So LLM gave response. US state got their name from the variety of sources. Okay. So now we have two information. First one is how did US state get the names, and the second one is US state got their name by variety of sources, and then retrieve section happen. In that case, what will happen? It will generate three different prompts with these two things. How does state get name, and this is the information will be given as a context, and then it will give the response like this. The second one is also given, and it will get the response like this, and the third one is like this. So in this case, what happened? The response is 11 out of 50 states name comes from a person. So that is relevant as well as supported. So what is happening here? Agents are working. Agents are understanding that these two questions are uh, based on these two questions. This is the response. But rag are sorry agents are also saying that Texas is named after Native American tribe, which is not appropriate response for these kind of questions. And the third is it is relevant, but it is partially related. It is not 100% related, it is partially related. So in this case, it won't, use these things. Now, what the critic output and select base segment, it will also done by agent. And that agent, what it will do, it will fetch the relevant and supported thing at first, and the second one would be relevant and partially dependent, and the last one would be irrelevant one. Okay, so it is doing the re-ranking approach which I have talked earlier. And in this re-ranking approach, you can see this is first one, this is third one, and this is second one, and later on there might be fourth one, fifth one, sixth one, and so on. So there might be so many retrieval which can, we can give the retrieval value k as how many numbers we want. Okay, and that number of data will be fetched from, our database. I mean vector stores. So here the it will happen in a repeat manner, that once agent is satisfied with the response, then only it will give back to user. So let's read the response which is generated by agents as well as by using self-reg approach. So US states got their name from variety of sources. This is the response from LLM. Then 11 out of 50 states name are come from persons. That is the first response from the prompt one. And then 26 states are named after Native Americans, including Utah. Okay, and here that is the fourth one, which will happen after this. There might be fifth or sixth, and the response would be bigger or more appropriate, whatever we decide. So yeah, so that is all for today about RAG system. If you want, I will definitely make a video of each type of advanced RAG techniques in Python code, or Python notebook, whatever. But yeah, I'll create a video out of it, and then we'll see how we can, what type of use case which is appropriate and where we can use it. Yeah. So thanks for watching. If you find it useful, please do like, subscribe, and share with your friends and your colleagues. And yeah, please subscribe to my channel. Thank you.